So let's go ahead and jump to today's notes, which is section 1.3. Section 1.3 is just covering two concepts, midpoint and distance. We've already talked about the distance on a number line. We're going to talk about midpoint and distance formulas on both number lines and in a coordinate plane. So let's start with midpoint. The midpoint is defined as the point that divides a segment into two congruent segments. So by definition here, if I take this point M and I place it on this segment AB so that it, notice the tick marks here, so that it creates two congruent segments where AM is congruent to MB. Those segments are the same. Remember, if two segments are congruent, then that means that their measurements are equal. So if I turn this into the measurement form with no symbols above, I use the equal symbol. And so those are the two relationships that exist for the midpoint. And when I look at this as a set of coordinates, remember lowercase a and lowercase b represent the coordinates of our endpoints A and B. The midpoint is going to be the average of those. So the calculation for the midpoint is equal to the average coordinate of your endpoints, and because those are A and B, the average is the sum of them divided by 2. So if I want to find what is the coordinate of my midpoint on segment AB, I take the average of the coordinates, so A plus B divide by 2. And so see if you can do that calculation with the given problem. So midpoint's going to have two formulas. It's going to have a formula for a number line like this, and it's going to have a formula for a coordinate plane, which we'll see in a couple slides from here. So if we wanted to calculate this, our midpoint's coordinate is going to be located at the average of these. So I take the sum of x plus t over 2. So there's my formula. Now, this part is probably unwritten, right? You guys just infer this. And so if I'm calculating, I probably just start with the negative 14 plus the 28 over the 2. Now remember, I strongly encourage you to enter as many answers as possible just as calculations. This is how I would recommend you enter your, oops, that's a 28. I would recommend you enter your answer this way, negative 14 plus 28 all over 2. And this will give you a preview of the answer, which if you were to physically calculate this, you get 14 over 2 or 7. You'll see that preview here on the side. But if you enter an answer as a calculation, it prevents the possibility of some careless mistakes in either transferring your answer from the calculator into the answer field, or hitting the wrong button or forgetting something. And it also just allows me to see your work, so that would be the way that you can show your work in this class, is to enter answers as calculations instead of just the numerical value. It's up to you. You can do either one. Okay. Questions on calculating midpoint? Right. The word midpoint is closely related to this next term, which is called segment bisector. There's a slight difference. A segment bisector can be any type of element. It can be another segment, a ray, a line, even a plane, and even a midpoint or a point. Okay, but a segment bisector is going to be an element that cuts a segment into two congruent parts. So notice it's almost the same definition, but it's less specific. It's any element that will divide that. Okay, so what you see right here is line CD, segment CD, ray MC. All of those are examples of different segment bisectors. So how many different segment bisectors do you think I could draw through point M on that diagram? Is there a limit? No, there's an infinite number of segment bisectors through any given point, but how many midpoints are there? How many points lie on that segment that cut it into two? Just the one, right? M is the only midpoint. So that's kind of how they're distinct from each other. The midpoint is a little more specific. Okay, so the relationship that you're going to see here, it's still the same if we were finding coordinates, but this is just the relationship that, once again, segment AM and segment MB are congruent segments. And if we're working with their actual lengths in calculations, then those lengths will be equal, and we can work, just like we did with segment addition, we can work to calculate these. Notice also the tick marks here to indicate the congruence is used for that. All right, so I want you to try this problem below. See if you can find what is V and what is the length of CQ, given that Q is the midpoint of CG. So for a problem like this, if I am looking to set this, I have Q that's a midpoint. That tells me that these two segments are equal, where QC and GQ are equal to each other based on definition of midpoint. I can then plug in the expressions for those. So 7V plus 9 is equivalent to 15V. And then I can solve this equation for V. There's the first part of my answer. When I solve a variable or an equation with a single variable, I'm going to move all the like terms to one side. So if I subtract through this, I get 8V is equal to 9, divide by 8. So I get my answer as 9 over 8. If I write 9 over 8 into my answer field, I'm going to see a little preview over here of the decimal equivalent. Now, this is a terminating decimal, so this is an actual exact number too. So you could plug in 1.125 because that's exact number. But if you get a decimal that continues on and then you cut it off and round it anywhere, or just even if there's more decimals that fall after what you enter, then don't enter that decimal form, use the fraction form. And in fact, again, just use the fraction form. It's always going to be an easier way to enter your answer. So if I want to find CQ here, what I can do is I can take the expression for CQ, which is 7 times V plus 9, but instead of writing V, I'm going to replace V with the answer that I calculated in the first part, 9 over 8, and that's going to be my solution for the second problem. And that's again, this is probably the most efficient way to write your answer. Once again, you will see a little display down here that the answer is 16.875. It again it's an exact answer. It's a terminating decimal, so an exact answer. So you could have used that, or you could have used the 1.125 in here, but these are your solutions. Either form will work for these types of questions. And so there's one other midpoint formula to be aware of. We looked at the one on a number line, which is just the average of the coordinates. When you're dealing with a point in an ordered, or the ordered pair of 2 points on a number or on a coordinate plane, then the midpoint formula is the following. Okay, and I'm going to set it up as represented as two separate calculations, but they are connected, and I'll draw in both. Okay, so the first is for each individual coordinate, the x-coordinate and the y-coordinate, the coordinates are going to be the average of the other 2 points, the endpoints coordinates. So the x-coordinate of the midpoint, that's what that subscripted m represents. So the x-coordinate of your midpoint is the two x-coordinates, average value. So if you take the average of the two x-coordinates, that's going to give you the x-coordinate of the midpoint. And if you want to find the y-coordinate of the midpoint, you do the same thing, but with the y-coordinates. You take the average of y1 plus y2 over 2. Okay, so what this means is each of these kind of is represented as an individual or distinct calculation, but they are going to be put together as an ordered pair. Okay, so you do get x1 plus x2 over 2 as the x-coordinate, y1 plus y2 over 2 as the y-coordinate. So this winds up being the entire coordinate of your midpoint, but you find each one with a separate calculation. Okay? So see if you can find the coordinates of your midpoint given the 2 points, 7, -8, and 3, 11. Do be aware of when a question is asking you to find an ordered pair and when it's asking you just to find a value. So the midpoint is a point that has an x and a y coordinate. So when you find the ordered pair, it's going to be the formula in blue. We're going to take the coordinates of the average coordinate of our x's. So 7 plus 3 over 2. And then the y's are going to be the average coordinate of our y's. Negative 3 plus 11 over 2. If you enter this as your answer, you'll see a preview. That preview is going to have the solution 5 3/2. And so either of those is acceptable and will give you full credit for that question. Now, if you were doing this by hand, which also is fine, you could continue. 7 plus 3 is 10/2. Negative 8 plus 11 is 3/2. 10/2 reduces to 5. 3/2 carries along. And so you're going to get the same answer either way, but a calculation is fine. You can enter your answer in that calculated method. Okay. Questions on this? Once again, you probably have done this. You should have done this last year too. All right, I'm going to save that question right below it for last because that's the hardest question in the section. But let's jump to the right. I want you to see if you can plot the correct point, plot the midpoint of AB given the diagram that's represented. When you do enter points on a graph, you will select the dot command, and then you'll place that dot where you need to. You have two options here. You can find it by calculating the coordinates of A and B, or you can use a counting method to just count and find what's the halfway point or midpoint between A and B vertically, what's the midpoint between it horizontally, and that is going to be where your midpoint falls. So solve this either visually or calculation based, and I'll go through it here in just a moment. Show you the calculation first, and then I'm going to show you, since most of you did that, and then I'll show the counting. So if you're calculating this, what you're looking to do is you're finding the coordinates for each. So B has an x coordinate of negative 3, a y coordinate of 12. A has an x coordinate of negative 9 and a y coordinate of negative 8. And so you can calculate the midpoint by taking the average of their x coordinates. And I'm just going to start up top. So negative 3 plus a negative 9 over 2, and the average of their y coordinates. Starting on top, 12 plus a negative 8 over 2. And then when I calculate this, I get negative 12 over 2. And for the y, I get 4 over 2. Continue to simplify what I have. I get negative 6 and a positive 2. So negative 6, positive 2. I'm going to choose my dot command, plot my point right here, and that is my solution. As long as you get the point plotted, you're good. Now, if you were going to solve this by just counting, it's based on this definition anyway, right? X coordinate is the average of the x's, y coordinate the average of the y's. So if I look at my x's here, from A to B is this distance. It's 1, 2, 3, 4, 5, 6. So I can cut that off in half, and if I look halfway between, I see where it's going to cross my line, and I'm done right there, right? I just need to find where the point crosses that. So it might save you that little bit of time doing that, even with the calculations. As long as you get one of those, either the x or the y calculated, you'll find that there's only one point that has that. If I do the same thing with my y's here, from 12 to 8, so that total distance, it's 12 up here and 8 down here. That gives me a total distance of 20. So I need to count 10 from each, right? So 10 up from negative 8 is the positive 2. 10 down from 12 is the positive 2. Whichever way I wind up going, it gets me to the midpoint of the y's, and where I see where that crosses my the line, the segment AB, and that would give me my point as well. Okay? So you can solve it visually also. All right, so let's take a look at this next question, this last question here, and this is the hardest question. Okay? And the reason it's harder is this one's a little more outside the box. It's not exactly the formula that you have, but you're given enough information. You're given the coordinates of the midpoint, negative 2, negative 1, and you're given the coordinates of one endpoint, negative 10, 4. Can you find what the other endpoint z's coordinates would look like, or what they would be? Okay, so here are my two calculations. Okay, my x-coordinate and my y-coordinate separately. If I know that my midpoint has an x-coordinate of -2 and a y-coordinate of -1, notice I can plug those in on the left side of sides of my equations. And then on the right side, I have an x. I'm going to call this x2 and y2 and say that I'm finding x1 and y1. So I have an unknown x plus my known x of -10 all over 2. And for my second one, I have an unknown y plus my known y, given as 4, all over 2. So there's my two equations. I plugged in the coordinates that were provided, and now I can solve each of these equations. Multiply both sides of 2 to get rid of my fraction. -4 is equal to x minus 10. Add 10 to both sides. I get x is equal to 6. So there's my x-coordinate. And for the y's, multiply both sides by 2 to get rid of my fraction. Subtract a 4 from both sides. I get -6 is equal to y. There is my y-coordinate. Okay, and so those would be my answers here, or my coordinates. All right, the final concept that you're going to see in 1.3. And if you do need to see any of the slides again, I'll go back and post them if you need to. Okay, and that's the distance formula in a coordinate plane. Remember, we already talked about distance on a number line, right? It's the absolute value of the difference of their coordinates. But when we get to a distance on a coordinate plane, we get the following equation, or following formula. Okay, it's based on Pythagorean theorem. You can kind of see from the right side how it's derived. But the distance is going to equal the square root of the difference of the x-coordinates squared plus the difference of the y-coordinates squared. And so this would be your distance formula given 2 points on a coordinate plane. Okay, so see if you can apply that here in this problem below. And once again, anything calculation-based, enter your answer as a calculation and you're good. So I have my x and y coordinates here. I get the square root of the difference of my x's. So 4 minus 9 quantity squared plus the difference of my y's, -1 minus 10 squared. This is all I have to do. If I just enter this, I'll see in my preview over here the decimal equivalent of approximately 12.08, and that would be an acceptable answer. Now, if you do this by hand and continued this, you get a -5 squared plus -11 squared, which would continue to simplify to 25 plus 121, which would continue to simplify to the square root of 146. So you could have entered your answer as that. You could have solved it as a decimal, rounded to the number that it asks you to. If it doesn't specify, like this problem, I didn't have round to a specific answer. As long as you round to 2 or 3 decimal places, you should be good.